In this video, we're going to be calculating the gradient of lines that pass through two sets of coordinates, 2 points. So in this one here, we have the point 3, 5, and we also have the point 7, 13. Now, one thing that you can choose to do is make a rough sketch of where these are. You don't have to do this, but for the purposes of talking through the rest of this, it will be of benefit. Your formula that connects the gradient the formula that connects the 2 points in order to find the gradient is given as rise over run, but when you have coordinates, your rise and your run need to be clarified as the difference between the x coordinates and the difference between the y coordinates. Now, I should have really used a different color here, but if I make that the difference between the y's, in other words, the difference between the height of the first and the second point, and then the width here will be the difference between the x's. So in this case, you have 7 minus 3 for the difference between the x's to give us 4. And for the height, we have 13 minus 5, giving us 8. And then we take the rise over the run, so we're going to have 8 over 4, 8 over 4. And from there, we end up with our gradient as being 2. Okay? Another one. You're asked to find the gradient between, this time, points minus 2, 10 and 4, 7. Now I'm going to do this one without a picture, alright? So we have our points here. What you have to be careful of with this, if you're going to just jump in at the formula, is define what each of these values are. So one of them has to be x1, y1, and the other has to be x2, y2. Doesn't matter which one you make as the 1s and which one you make as the 2s. As long as the x's are the first number and the y's are the second number, you'll be okay. So our gradient, again, the difference between the y's, y2 minus y1, divided by x2 minus x1. And then it's a case of substituting in, and be careful with any negative numbers you might have. So y2 is 7 minus y1, which is 10, all over x2, which is 4. Subtract x1, which is minus 2. So be careful with this. 4 subtract minus 2. From there, we end up with minus 3 on the top, 6 on the bottom, and that's going to simplify to either give you a half, or if you prefer to write it as a decimal, negative a half, or if you prefer to write it as a decimal, negative 0.5. Lastly, and again, we'll just go for the formula for this one. Label your coordinates. I'll do this one the other way around this time. So x2, y2. No, actually, that's what I did last time. x1, y1, and x2, y2. It doesn't matter which one is the 1s and which one is the 2s. Again, our formula, y2 minus y1, the difference in heights, the rise, over the difference in x's, the run, the width, and then substitute the values in. So minus 8 is y2, take away minus 5 for y1, x2 is minus 6, take away 4 for x1. Careful with the top here, you end up with a minus 8 minus minus 5, which will become a plus, giving you minus 3 overall. The bottom becomes minus 10, and you would then simplify that by either cancelling the negatives to give you 3/10, or you could also write it as 0.3.